and welcome to the V1 Cut video prep, video briefing here at One Step Prep. I'm your instructor, Joe Munoz. Today, we're going to go through a very important part of your training as well as check ride, and that is the V1 Cut. That's right, the dreaded V1 Cut. And after you get through this briefing, it won't be so dreaded anymore, and we're going to show you exactly why. Now, keep in mind, as mentioned, this is one of the main items, the heaviest weight in that check ride. And ultimately, if you're looking for that magic signature to be coming from that examiner with this giant pen here, you're going to want to know how to fly this with ease, no problem at all. And we're going to show you how to do that right here, right now. Alright, now the first thing I want to talk to you about is the V1 Cut. And there's three parts I'm going to talk to you about today. We're going to start it off with the V1 Cut, and then we're going to go into the single engine ILS, and then we're going to move into that single engine go around. Keep in mind, if you take off and have a V1 cut, you're of course going to have to come back and do an approach, and on your check ride it'll be a single engine ILS, it has to be, and then we're going to have that single engine go around, which invariably you're going to have as well. So single engine operations are coming to a simulator near you, expect it, don't be surprised, right? So the first thing, let's start with drawing this, this runway here on the board. Alright, and this is our runway, and what we're going to look at first is when the actual V1 cut happens. Remember, it's just as it sounds, it's right at V1. It should be right at V1. Occasionally, okay, depending on how the sim's programmed, you find that the pilot monitoring will call V1, and then no engine failure for some reason. You're like, oh, what's going on, you know? And finally you start rotating the airplane, and then next thing you know, oh, now the engine fails. And it's kind of more of a V2 cut. If everything's programmed properly, it should happen right at V1, which is the easiest time, really, because you're still on the runway. You've got visual reference. Now, one thing you've got to understand about V1 is that VR, or that rotation speed, comes shortly thereafter, and what we see in the sim, time and time again, is rushing, right? We have this pilot flying in a position where the engine just failed, and now he or she's hearing V1 rotate, and it's almost like that initial panic sets in, and the rotation is aggressive, and it's take your time, slow down, take your time. Something you got to realize, when the pilot monitoring says rotate, it is simply an acknowledgement that we have reached the rotation speed. By no means should you mistake that and think that, oh, the pilot monitoring is commanding me to rotate. No, 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 no. Take your time, all right, go nice and slow, and you're going to want to go easily, and I'm going to tell you why here in a minute. Now, at the same time, don't fall asleep on the runway, right, because we still got that second segment climb to be concerned of and be mindful of. But you do want to take your time, right? So as I call V1, slowly, okay, VR's coming up, and you're going to want to rotate. Notice how I elongate that, right? So you slowly rotate, and essentially what you're doing is we're trying to track parallel to the center line, all right? So let's go ahead. Here's a top-down view, all right? Here's a top-down view of your runway, and what we're seeing is this center line, and invariably your aircraft, and we're going to say hypothetically the number 1 engine has failed. So the number 2 engine is still pushing, and of course the airplane is going to have a left turning tendency as a result of that. Okay, now with this, all you need to do, pilot flying, is apply the applicable rudder pressure in order to at least parallel the center line. You don't need to go necessarily right on top of it, but certainly that'd be preferable, but you need to be at least parallel to it. Okay, now the reason why is the following, and I'm going to give you this quick example. Let's say, for example, okay, just as we saw in this particular case, we have this aircraft. We're going to go ahead and let me give you these engines here, nice and largely drawn. Number 1 has failed. Number 2 still pumping, and here we are, right, with our rudders, our rudder pedals, specifically left and right. And now the question becomes, how much rudder pressure do you need to keep the aircraft centered, straight, okay, going straight, parallel? And who knows, let's say 5 pounds, right? And it's going to be, of course, in this particular case, it's going to be 5 pounds of right rudder pressure to stop that left turning tendency. Okay, so we got this 5. Now, is this the actual number? Don't know, right? Don't care. It doesn't really matter. But the point is, I just want you to understand right now that 5 pounds of pressure is going to be appropriate for the given airflow over the vertical stabilizer. Let me clarify that. All right, so you have this vertical stabilizer. Here's a nice large image of it, okay? And of course you've got this rudder back here, and that horizontal stab, okay, is over here. Now, air flowing over this vertical stabilizer right now is how much? Well, we're at the rotation speed, just as we saw, right? We're at that VR speed, so we're actually relatively slow in the grand scheme of things, in the bigger picture. So you may be at a speed of, somewhere in the range of 134 knots indicated airspeed. That's the amount of air flow that your horizontal stabilizer is feeling going over the top of it right now, okay? Now, for 5 pounds, okay, it might be more, it might be less, but we're going to use the example of 5. So 5 pounds of pressure right now is required to keep the airplane tracking parallel with the center line. Remember, you're going to turn off slightly as the engine fails, and then you want to go parallel with it. Be careful if you decide to go back towards the center of the runway, only because the objective is to fly through the goal post. Let me elaborate on that, all right? Here's your goal post right over here, okay? Just like such, okay? And the objective is to rotate that airplane, and you're gonna go right through the goalpost. Now, why do I use a goalpost as a good example of this? Because a goalpost, if you look at a goalpost head on, okay? Here's a goalpost right here, head on. The objective is put the airplane dead center, and you only have 10 degrees left and right, and that is your PTS standards, your tolerance, right? Your practical test standards dictates you must be able to maintain plus or minus 10 degrees on a V1 cut, okay, on an engine failure. So essentially, if you can keep the airplane parallel with that center line, you know you're going to go through the goalpost. The issue becomes when sometimes you start trying to track, okay, that center line perfectly. And what happens is when you do that, now you need more than 5 pounds. Because if you deviate it off here to the left, you may need up to 7 pounds of rudder pressure in order to get you going in the right direction, to the right, literally here, in this case, back to the right, right? And the issue is if you do not later on adjust that to not have you flowing over to the right side, but more to be keeping you straight, it is possible for you to continue tracking right and go outside of that 10-degree boundary that you have. All right, so now here we are climbing out at this point, okay? And in the climb out, initially, what we're gonna do is just go for that rudder pressure, okay? As mentioned, you're gonna hold it steady, preferably. You don't wanna ride the bicycle too much, all right? Just place that pedal there, hold it steady, and the deal here is rudder trim. Can you use it? Should you use it? What's the deal with that, right? Yes, you can use rudder trim, just something to be mindful of, okay? There's a few different methods that are taught, okay? And usually the first one is fuel flow, okay? Instructors will say, hey, whatever your fuel flow happens to be, that's about how many units you need. So if it says 6,000 pounds or 7,000, 8,000, whatever that happens to be, 7 units of trim, 8 units of trim, and that's assuming your fuel flow is in pounds. Remember that, it's only if it's in pounds, okay? Now, the alternative to that would be maybe using the 853 method. And what is that? Okay, let me show you what that is about. 853. On the takeoff phase, you want 8 units. On the cruise phase, you're going to want 5. Okay, I'll make that look more like a 5. And over here, in the landing phase, you're going to want 3. While this is good, and it will work, okay, it can provide other complications for you. And so here's the golden rule. You ready to know what we teach here at One Step Prep? This is what we teach and preach at One Step Prep. And that is, okay, it's not the 853 and it's not the fuel flow. You ready for this one? Here it is. It is... There you have it. The number 4. All right? 4 units of trim, regardless of where you're at, and you're going to be golden at all times. Let me show you why. All right? What's happening with 4 units of trim is the following. Keep in mind, you've just rotated. Here's your runway, okay, right? We just rotated off, and basically as we climb out, eventually we're going to get to this acceleration altitude, or that level off, where we're going to kind of lower the nose, we're going to accelerate the aircraft forward and begin that flap retraction. Well, here's the thing. Rudder pressure requirements vary directly with the airspeed that is sensed over the vertical stabilizer. So, you noticed over here I put 134 knots indicated initially, right? And we had about 5 units of pressure, or 5 pounds rather of pressure. Is that the number? Don't know, don't care. But here's what you do want to know. As we're climbing out with that engine failed, your speed's still relatively slow. Okay, you're in the range of the V2 to V2 plus 15 area. So in terms of what we're feeling over the vertical stabilizer, you're looking at anywhere maybe in the range of about 150-ish knots or so, which is not a lot. Okay, it's not a lot. Now, 150. Keep in mind now, as we get on up, okay, we climb and we're climbing and we're climbing. And eventually, as mentioned, we're going to get to this level off, or this acceleration altitude, and now's the point where the nose will come down, we'll begin accelerating forward, and quickly this number is going to start climbing. It's going to be from 150 to 160, 170, 180, and as mentioned, right, remember, the amount of rudder pressure applied to the pedal varies directly with how much airspeed the vertical stabilizer and therefore rudder is sensing. So the amount of rudder pressure required as the airspeed accelerates will be less and less and less. All right, and you may find that, hey, 5 pounds is no longer required, so now maybe I only need 4 pounds. And maybe after you accelerate to 200, 4 pounds is too much. Maybe now I only need 3 pounds or 2 pounds, right? And so the issue becomes, with the 853 method, remember in the climb is where you needed the 8, and in the cruise, or in that level off rather, is where you're going to need the 5. How long are you actually in the climb phase of your initial part here of this climb out? How long are you actually climbing in that initial phase before leveling off at the acceleration? Not that long. You're not climbing that long. At least not long enough to warrant putting 8 degrees or 8 units of trim. And the reason I say that again, because now as you level off and you start reducing to get that back to 5, okay, it becomes a lot of rudder trim adjustment. And the focus needs to be on the attitude indicator to make sure the airplane's not rolling over, not on, let me make sure my rudder trim matches fuel flow, let me make sure my rudder trim is set to 5 units or 8 units. You don't want to put that much attention. What you want to do is reach back, focused 100% on the attitude indicator, reach back, just feel for it, or even command it to the pilot monitoring, hey, set me 4 units of trim. That will be enough to relax your foot a little bit, not entirely. You still need pressure on the pedal for the initial climb phase right here, which is a good thing because you want to stay tactilely connected with the airplane. You don't want to be able to take your feet off the pedals entirely. And now when you go to accelerate, you're already at 4 units, so you're in a good position still to not have to mess with that rudder trim at all. Now, something to keep in mind with engine failures, okay, today we're talking about the V1 cut because that's what we do in training. But ultimately, when we're out there flying, an engine failure can occur at any time. I mean, it doesn't have to be a V1, it could be a V2, it could be climbing out. You could be climbing out, you just took off, next thing you know, you got a bird strike coming straight through your engine, right in, and then next thing you know, you find yourself single engine, and it doesn't have to be a V1, right? Here is climbing out, and here we have a bird strike, and now you're left to fly the airplane single engine and hopefully apply the techniques that we're going to show you here today to make it easier on you. Now, the next point of discussion is going to be the single engine ILS because frankly, the V1 cut is the easiest part of the 3 sections that we're going to go through. Remember, it's 3 parts, right? The V1 cut, the single engine ILS, and then of course the single engine go around. The majority of the additional training and remedial sessions that we've given is almost always for the single engine ILS and the single engine go around, and never really the V1 cut. The V1 cut is actually quite simple, and that's because why? You've got visual reference outside to the center line. And as long as you can keep yourself parallel with the center line and rotate the airplane off, you're pretty much going to fly right through the goalpost. You're going to stay within 10 degrees and everything is within tolerances. So not too big of a deal. Now here, we're going to move into that single engine ILS. The number one thing I need to tell you about the single engine ILS is flight director tracking. Flight director tracking, okay? Let me explain, let me elaborate. In fact, we're going to get creative here. We're going to bust out the second color marker, and we're going to go with a little bit of a dual color here. And the first thing I want to point out is the fact that your flight director, okay, depends on if you're using a single Q or dual Q, but the majority of flight directors that you find are these dual Q, like such, right? Where you have your vertical and you have a lateral deviation bar, both up top and on the bottom. Now, here's the situation with this, okay? The airplane symbol if you look at your primary flight display, okay, you look at the attitude indicator, the airplane symbol looks like that. It's got a little square in the center. Now that square must be dead center on the flight director. And what I mean by that is this square needs to be right here and needs to actually become 1, 2, 3, 4 little squares. It's got to be dead center so that your airplane symbol is right where the flight director is intersecting. And the number one issue we see all the time is the fact that the aircraft symbol is not right centered on the flight director. Let me give you a good example of that. Notice the aircraft symbol not perfectly centered. Okay, not perfectly centered, and it may look like it. Keep in mind on the PFD, we don't have this giant airplane symbol like this, like what I'm drawing here. We have a little tiny little screen, okay, depending on it, even depending on the airplane you're flying, okay. Some are larger than others, some displays are smaller. By no means am I saying to fly this thing with a magnifying glass, okay, you're not trying to put but be as particular and as specific as possible when you're going to track this, okay? And the reason I say that is because this is huge when you start getting close. Keep in mind, on an ILS approach, okay, and even on a localizer, you have a cone, okay, is basically what it is, and you're flying in this cone, and out here, when you are out here, that little deviation like that, it may not be too big of a deal because you're in the wider area, but as you get inside and this starts tightening up, that will become your worst nightmare right there, because now you get full scale deflection, which is not going to be a passing score for you, not in training and also not on the check ride. You've got to have a fully stabilized approach, and that includes being centered up on that localizer. Now the question becomes, why does this happen and how do I prevent it from happening? The reason this happens is because if your runway is over here and you're coming inbound, okay, and you start down, and of course as you're coming in, you have varying speed conditions on the vertical stabilizer. Remember, as we saw earlier, okay, here's your vertical stab with that horizontal stab. You got your rotor right over here, and the airflow that is being sensed by the vertical stabilizer and rudder, okay, is varying because maybe out here you're putting flaps 1, and then you decide to go out and put another notch of flaps, and next thing you know, you got the gear coming down, and before you know it, you got your almost to that final flap setting. And every time we're configuring the airplane, the amount of airflow, I'm just going to put X, okay, whatever the airflow happens to be, that is over the vertical stabilizer, keeps changing as the configuration changes. And every time there's a speed change like this, where that config is changing, which is causing the speed change, right? Now you have a need to vary the rudder pressure that's being inputted. So now, instead of having, let's say, 5 pounds, maybe you need a little bit more. Now because your speed's slowing up, right? Maybe now you need 6 pounds, 7 pounds, 8 pounds. Gear comes down. Now I need 10 pounds. And what happens is, as these configuration changes are happening, people start playing bicycle, and they're riding it around all over the place, and next thing you know, this square is not perfectly centered, and you finally realize it when it's too late and you're too close in on the cone, and your full scale deflection, you've got to go around, it doesn't look good, it's not stable. So let me try to help you a little bit with this. The number one piece of advice I can give you for this is, do not adjust your rudder trim constantly while on the approach. You're fighting with the trim, all right? What do I mean? Let me elaborate, let me give a little more detail, okay? If you're coming in on this approach, and we'll draw your runway down here once more, and here you are coming in, making your config changes. Remember the number, the magic number that we preach here, which is 4 units, okay? So 4 units is gonna work for both, and actually all 3 phases, right? Climb, cruise, descent. And here we are coming in for landing. If you can set 4 units of trim, the amount of air flowing over this, remember, over the vertical stabilizer, we mentioned that the airflow over that vertical stabilizer is therefore directly proportional with how much pressure you need. So the amount of rudder pressure that you're going to need at 4 units initially, let's say, is somewhere in the range of 5 pounds. Okay? And next thing you know, you put flaps 1. Now when you put flaps 1, you're going to start reducing speed, obviously, right? Speed starts slowing down, and with a reduction in air, okay, ambient air flowing over that vertical stabilizer with a reduction of airflow, that will call for additional rudder pressure because the rudder is less effective. So now you need more pressure. Leave the trim at 4, okay, but just know that when I go flaps 1, I need a little bit more pressure because the reduction in speed calls for more pressure. So I start adding. Next thing you know, you're going to go with your next flap setting. And you're going to go with your next flap setting, you're going to get the gear down, and before you know it, you're fully configured. If you can keep the rudder trim right here at 4 units, just know that every time you make a configuration change, all you need to do is apply a little bit more rudder pressure because the speed is decreasing, right? Until finally we get to our approach speed, right? That V reference our V target speed more or less, and we're going to stay right there. So we're going to decelerate to a known value, a known point. But the common thing that, again, as mentioned, is the deceleration. Every time we make a config change, we know it's because we're slowing down. So if we can keep the rudder trim the same, we know that every time we make a config change, we need more pressure, more pressure, more pressure. And that is going to help you immensely to keep that vertical and lateral command bar of the flight directors centered and perfectly square every single time. Now, the magic moment has arrived, which is the single engine go around, and this is probably the area that gives pilots the most trouble. And the reason is there's no visual reference outside, and you're in a position where you're at a low thrust setting, relatively, low, in comparison with where you're about to go, which is toga power, and now you got to spool the engine up and keep the wings level, no more than 10 degrees left and right, and also you got no visual reference outside. So this is one of these things where you've got to be well briefed and prepared mentally to do this. So let's talk about it. Here you are on this approach. Okay, we'll say we got the runway out here. I'm going to give you another one a little bit larger here. Here's your runway, and the aircraft, as mentioned, still same scenario. Number 1 engine is failed. Okay, number 1 engine is failed over here. Number 2 is pushing, and we'll say hypothetical situation. How much power does it take? We'll say 65%. Okay, depends with altitude, right? Depends on weight of the airplane. So here we are, 65% N1. How much rudder pressure is required to keep the airplane tracking straight with 65% N1? Right? We're going to put our rudder pedals here. Now, the value is kind of an unknown. We really don't know, really don't care, but what we do want to do is tie the two numbers together. So on the right rudder pedal, let's say we need hypothetically 5 pounds, right? 5 pounds of rudder pressure for 65%. What you're going to find is as you get to that DA, okay, you got to make that go around decision, and invariably you're going to go around. Something to keep in mind on a check ride, always your first ILS approach, single engine, will result in a go around. It has to, because you're going to be doing, they have to see a single engine go around, right? So keeping that in mind, don't ever think you're going to land on the first one, right? In fact, this is a case for every single landing, even 2 engines, normal day, normal flight. Always be in the mindset of I might have to go around, and you're certainly going to be doing it here on this check ride single engine. So now here's the deal, right? 5 pounds, 65% N1, and when you get to the decision altitude, you get down to that DA, okay? No runway in sight. We're going to execute the go around. What we need to do is apply thrust slowly. We're going to apply thrust slowly, and 65% is not going to be the go around thrust value. I promise you that. So it's going to be somewhere in the range more of around, let's say 95%, okay? Is that the value? Who knows? Who cares? But we're going to throw a higher number because it certainly will be up there. And we're here at 95%. Now, is 5 pounds, okay, is 5 pounds of rudder pressure enough to keep the aircraft straight at 95% N1? No, it is not, right? If you guessed that, you're correct, right? We're halfway there. All right, so now we need more. How much more do we need? Let's say, 10 pounds. And again, is that the number? Don't know. Don't care. But, okay, tying two numbers together. So we got 10 pounds. We got 95%. We're on the right track. Now, here's the challenge, right? For you to go from 5 pounds to 10 pounds of rudder pressure, how quickly can you do it, right? How quickly can you go from 5 pounds to 10 pounds? I'm going to tell you how fast. It's about that fast. You can do it super quick. Why? Because the rudder's mechanical. All you got to do is take your foot from one position, put more pressure, apply the pressure. You're in the 10-pound position in a half a second. and it's a lot faster than what your engine can do, because my next question is going to be, how long does it take us to get from 65 to 95% N1? There is a bit of a spool up delay. Okay, keep that in mind. There is a bit of a spool up delay. So commonly what flight crews will do is they'll say, and I'll brief them, okay, we give them the briefing and they, hey, when you apply thrust, you gotta apply rudder. And they always say, yep, absolutely, absolutely, I'm gonna do that. And then we go into sim, and for some reason, we still kind of dance around all over the place. Now, what we've come to find is the reason is this. The delay, the spool up delay, and the application of rudder. 5 to 10 pounds is quick, but 65 to 95 is not. So the objective is, as your engine spools from 65 to 75 to 85, 95, a little bit of a delay there, you're slowly feeding that rudder in. You're slowly feeding the rudder in. And ideally, we apply from 5 to 10 pounds at the same rate that the engine spools, so that we can keep the directional control of the airplane always centered straight with that center line. Now, how do you do that? Apart from practice, hours and hours and hours in the simulator, which A, your airline probably won't be paying for that much time, and B, if you're self-funding, you probably don't have an endless bank account to pay for hours and hours and hours of sim time. So let me offer you a little bit of guidance, and I think this is going to help you immensely to really lower and shorten that learning curve. Okay, the number one thing is, when you add power, invariably you need rudder, right? You know you need rudder when you add the power. So that's a good starting point. Let's add the power, and let's add the rudder a little bit. Okay, let's add a little bit of rudder. And what you're going to want to do next, okay, is you're going to want to look to your attitude indicator. Okay, and you're going to stay laser focused. And I mean laser focused right here on this attitude indication. And what we're going to do is we're looking for any indication of the wing dipping down. Let me clarify. You're going, why? So, wing dipping down, okay? Left wing right here is dipping down, right wing's coming up, and the objective now is that we want to step on the wing that's going up. So here, the right wing is going up because the right engine happens to be pumping, so you're going to be turning left, which is what's happening here. So we want to press down on that right wing. So initially, apply thrust, and remember, toga. You got to press toga is another big thing, right? Selection of toga, thrust application, and how much application of thrust, 1 arm's length. Toga thrust, or toga's push button, right? Slow application all the way up to 1 arm length. Once the arm length is there, release the thrust levers. They're not going anywhere. All right, you're going to go and fly 2 hands. And what you're going to want to do is, as you see that wing coming up, you're going to apply additional rudder pressure to keep those wings perfectly level. All right? Now, the next challenge, of course, is the call-outs, right? So not only do you have to fly the machine, you got to say the script at the same time. There's things that need to be said on both parts of the crew, right? Pilot monitoring as well as pilot flying, and we've got to have that memorized. Now, generally we see one of 2 things, okay? And sometimes it falls with both. And sometimes it becomes pilots that are having trouble with the actual flying, stick and rudder part of the actual maneuver. Then you have those that are not too sure on the call-outs, fly a great airplane, but not too sure on the call-outs. And occasionally, with rare circumstances, we see where the flight crew is having struggling or having trouble with the flying part as well as with the call-outs. Now, the first thing I would do is attack the call-outs, okay? Because the call-outs, you can practice them for free. You can practice them for free at home, in your hotel room, on your off time, anywhere you are. You can practice in your car driving. I mean, go through these call-outs, and for specifically, let's say here, single engine ILS, so you're going to want to go through your mind, go around, right? You're going to press toga, that's the action. So go around flaps 1, positive rate, gear up, 400 feet, heading select, 1,000 feet. Going to accelerate, right? I'm on speed 210 or bug up, right? So now, as you go through these call-outs, you're going to find you get to a point where you're chair flying, you're staring at a wall, and you can say them perfectly. Everything's great. The challenge now becomes when you go into the simulator, for some reason, it doesn't come out as good as maybe when you were doing it on your own in your hotel room, at home, in the car. It just doesn't sound as smooth and crisp, right? Why? Because now you have a distraction, which is flying the airplane. You gotta fly the airplane. And before you were able to do it because all you were focused on was the wall. Nothing, right? You're just your chair flying, you're looking at the panels or whatever. Nothing actually dynamic and moving, and now you're flying the airplane, you gotta do that too. So our recommendation, grab a piece of paper, grab a book, any flat surface you could hold in your hands, grab a marker, pen, pencil, whatever you may happen to have, toss it on top, and the objective and the idea here is we're going to roll it back and forth. We're going to do the call outs at the same time, right? And the objective, again, this is the distraction. This is the flying the airplane part. So this is the distraction, and you've got to get these call outs at the same time that you're doing the distraction, right? So go around flaps 1, positive rate, gear up, 400 feet, heading select, 1,000 feet, speed 210. And you want to be able to do this both, right? And be able to get those call outs at the same time so that when you go into the sim, you're maximizing your training, okay? You're maximizing the effectiveness of that sim session because you're not focused on call outs. Ideally, we want to focus on flying the airplane, and the call outs roll off your tongue, second nature, don't even need to think about it. It's all unconscious. I hope you found that video helpful. Please continue to review it. Go back, pause, play as many times as you think you need to do until you feel comfortable. And the key to all of this is practice, practice, practice. Continuous repetition is going to be the key to your success when you go into the simulator for your training and ultimately for your check ride.